Good morning, good afternoon, good evening. Today we'll be making this laser etching text effect. Etching is shallower than engraving, so we don't have to deal with geometry transformation. Logic to trace the text outline is simple, but filling the interior requires a lot more work. By the way, snake-fill text node introduced in past video is required to complete this tutorial. If you have not watched that video yet, please do so by following the link in description. Alright, let's get into it. As soon as we enter Blender, let's hop right into Geometry Nodes Layout. A to select all, X to delete. Shift-A, add Mesh Plane. Using numpads 7 and 5, go into Top Worst Graphic View. New to create a map. Delete Group Input. And replace it with String Input. Enter capital T. Pass it through Strings Curve, then Output. Now we got the letter T. We'll be making a laser etching animation today. So we'll have letters appear on metal plate like it's being etched by a CNC laser. Let's grab the snake-fill text node group we made in previous tutorial. I have this node group registered as an asset, so I can just search for it. But if you don't though, you can go to File, Append, then navigate to the blend file that contains it. Then append the node group to use it in this project file. For the snake-fill settings, set spacing to 0.01, H resolution to 0.001, and cutoff distance to 0.05. We should end up with the snake-fill splines in the shape of T. We also want the outline of T as realized spline. So branch out a realize from curve instance, then join these two spline results. We will be etching both the fill and outline splines. We should see 3 spline counts in the spreadsheet. To replicate etching, we want to grow these splines from nothing until it forms a T. So intuitively, trim curve feels like the node to use. Well, let's try it out. As you can see, with trim curve, we have all 3 splines growing simultaneously. I'm not a CNC expert, but I assume these machines only have one laser output, so this is no bueno. For this, I will not use trim curve, but implement a custom trim method. Okay, so after the join, we'll first resample with lengths of 0.01 to add more points. Next, insert a set spline cyclic to turn off cyclic. This is to avoid the outlines from connecting while trimming. Now, we'll insert a calculation to determine each point length's position relative to the entire curve length. Add a store named attribute with float point setting, and call it clen. Add a spline lengths node and connect lengths to accumulate field. Set accumulate setting to float spline. Then from trailing output, connect to math add and add it with spline parameter lengths. Be aware that this is spline lengths node and this is spline parameter node. Store this result as clen. Next, add a delete geometry. Grab the named attribute clen we just made, pass it through greater than, and connect to delete selection socket. We can observe the spline growing when we increase the B amount. Unlike how trim worked, this method grows one spline at a time. To animate this, simply connect a scene time to B and insert a mass multiplier for speed control. Laser etching is quite rapid process, so let's use 6 as a speed gain. Animation looks good, though it appears quite fast. Remember, we will be dealing with a longer text later. Let's now input a longer text. I'll go with test. Now when we animate, we see all the letters being etched from the bottom up. This kind of resembles how machine etching works, but I kind of want it processing a letter at a time. So let's make a slight modification. Create some space after strings to curve, then add a for each element. Change the domain to instance and reconnect. Now we have the letters appearing one at a time. Logic on spline level is pretty much complete. So let's change the text and font. I'll input CNC and choose a different font. I'm gonna go with this classical looking Old English regular font. We can skip to a later frame to see the completed text. I'll also move the alignment to center, middle, so scene is centered around the origin. Animation looks like this now. At this point, you might be experiencing dropping FPS with longer text. When we check the timing, we see that Snakefill node is not particularly CPU friendly. If you experience a frame rate drop, I suggest adding a bake after the store named attribute. Bake result should not change at any frame, but I like baking at frame 1. To get this to render, we need to convert the spline to mesh. Add a curve to mesh after delete, and use a curve line for profile. Set -0.5 to 0.5 for x, and let's try scaling to equivalent of spacing, 0.01. We got the mesh, but when we zoom in really close, we can see there are gaps in between fills. So for a better result, I recommend using scaling of 1.5x, the spacing width. Next, we want some kind of indication where a laser is hitting. To do so, we'll add a small ball of high intensity light at the current endpoint of the spline. First, branch out an instance on points from delete. We want to instance on the last index of the spline, so let's find that out. Add an index node, connect to field min-max node, and compare equal from max. Compare with index node and connect to selection socket. For instance object, we'll use icosphere. Set radius to 0.01 and leave subdiv as 1. Join the instance on points result with the curve to mesh result above. It's hard to see, but we now have tiny ball instance at the end of spline. We'll get this point glowing with material later. When we run the animation though, we see that the instance sphere is kept in the scene till the end. We want this ball gone when etching is complete, so let's add more conditions. We'll make it so the ball is no longer instanced when end of entire curve is reached. First, duplicate the named attribute clen. Then, grab the spline before deleting, and connect to curve length node. Compare clen with less than. Boolean and the result with end index condition to plug into selection. Now, when the ball reaches the end of entire spline, it is no longer instanced. though the last position will not have the etching light. The process is going to be too rapid to notice. Animation is complete, so let's move on to material setting. Add set material to top etching noodle and bottom laser noodle. Then split the window to open up a shader editor. New to create a new material, call it M Etching. Set this to the top set material slot in the geometry node side. In this animation, we are replicating metal etching on iron plate, so we'll use the basic iron metal setting. Set the base color to RGB value of 0.56, 0.57, 0.58. Easy to remember numbers. Set metallic to 1 and roughness to 0.2. That's all we're gonna need. Now for the laser material, click on this X to remove the etching material. Then create a new material, call it M Laser. Don't forget to set it on the geometry node side as well. Remove the principled and replace it with emission. Choose some laser color you like. I'll keep it white. Select the strength of between maybe 500 to 1000. This material will only appear as white ball currently in render view. Let's activate bloom to make it glow. We no longer need the spreadsheet, so change it to compositor. Then click on use nodes. Drop a glare filter bloom on this line. Now when we change the viewport compositor to always, we can see the icosphere glowing. We are done with both geometry and shader nodes, so let's move back to the original 3D layout for scene setup. First, we'll add the metal plate to be etched. Shift A, add a mesh plane. S to scale by 1.5. Then G, Z, negative 0.001 to lower it by tiny bit to avoid Z overlap. For this material, since it is the same material as etching, we'll duplicate the M etching. We want this shiny and reflective, so let's drop the roughness to 0.05. We'll check out how it looks rendered. Don't forget to set the viewport compositor to always. Now I have all the scene objects that I want, but metallic objects need something to reflect in order to look real. I don't want to spend time adding more objects, so I'll just add an HDRI. From World tab on the right, click on the tiny circle next to color, add an environment texture, and open to add a HDRI. I'll be using this Metro Nord HDRI I downloaded from Polyhaven. Most of you probably know, but Polyhaven is a great site that provides high quality free HDRIs, so check them out. Now we have the metal plate, reflecting background making it more metal-like. Alright, let's play the animation now. I think it looks decent. I like how the letters are being filled from the inside, and it's cleaned up by tracing the outline. I won't make the video longer by adding more detail, but you can play with spacing values, or add laser beams to make it more to your liking. Okay, let's go over the node we made. I'll do a little bit of cleanup though. Okay, I guess this is the overview. Let's now look at it from the left. That's it for this one. In the snake filled text video, I mentioned that it can be used to make CNC-like animation. Well, the original motivation was that I wanted to make this etching animation. So I had to make a fill logic to achieve this result. Snake fill was actually more of a byproduct, but I digress. Well, thank you for watching till the end, and hope to see you in the next one.